ever miss a step walking down the stairs in the dark, like, whoa, where'd the floor go?
Yeah.
That split second of panic, that's your proprioception going all wall.
It is. It's like your brain just totally forgets you have a body for a second.
And today we're going to deep dive into why that body sense, that proprioception, is so crucial for stroke recovery.
It's amazing how we just take it for granted. You know, until you try explaining to someone what it feels like to walk, and you realize you can't really put it into words.
Right. It's totally automatic. But after a stroke...
Oh, man. Even the simplest movements become a huge challenge. It's like learning to walk all over again for some people.
Exactly. And that's where this first study we're digging into comes in. Effects of lower limb proprioceptive training on balance and trunk control among the adult stroke population.
Catchy title, right?
Well, it gets to point across. But they looked at folks at least 6 months post-stroke. So we're talking chronic stroke here.
Right. So these are individuals who are well past that initial recovery phase.
And they wanted to see if specific exercises could make a real difference.
Because for a long time, it was mostly about strength training, right? The idea was stronger muscles, better balance.
Makes sense on the surface, but...
But it turns out it's way more complex than that. Proprioception involves this whole network of sensors.
In our muscles, joints, skin, all feeding info to the brain.
Exactly. It's like a constant feedback loop.
So in this study, they had 2 groups of patients at the Indian Head Injury Foundation in New Delhi.
Okay.
One group got conventional therapy, your standard strength, range of motion stuff.
Works.
The other group, same thing, but with added exercises specifically designed to challenge and retrain their proprioceptive sense. So like, imagine standing on a wobbly surface, eyes closed.
Oh, man. I'm getting dizzy just thinking about it.
Right. It forces your brain to work harder to figure out where you are in space.
And what they find, did all that wobbling around do anything?
Here's the cool part. Both groups saw improvement in their balance and trunk control after 4 weeks.
That's good news already.
Right. But get this. The group who did those extra proprioceptive exercises significantly better balance scores. Not just a little bit, but noticeably better.
Wow. So like they weren't just stronger, they were more aware of their bodies.
Exactly. Which could be huge for someone recovering from a stroke, right? Imagine being able to walk with more confidence, less fear of falling.
Absolutely.
Yeah.
Even small improvements in balance can have a massive impact on someone's independence and quality of life.
Totally. So this is where it gets really interesting to me, what's actually going on in the brain with this kind of training. Like, are we retraining the brain itself, not just the muscles?
That's the million-dollar question. And it seems like the answer might be yes.
So we're basically talking about like rewiring the brain, right? Not just getting stronger.
Exactly. And this idea of neuroplasticity, the brain's ability to kind of rewire itself after injury, it's like the hottest topic in neuroscience.
Because for so long, we thought that damage was like game over.
Right. But now we're realizing the brain is way more adaptable than we ever imagined. And this study hints that maybe, just maybe, targeted proprioceptive training could be nudging those neural pathways in the right direction.
Okay, so back to those sensors we were talking about in our muscles and joints. Those signals they send, that's the key, right?
Exactly. They're like the messengers telling the brain, hey, this is where your body is, what it's doing.
And if they get messed up after a stroke?
The messages get scrambled. So you might reach for something and your hand goes way past it, or you misjudge a curb and trip, those kinds of things.
And this training, those exercises, it's almost like we're boosting those signals.
In a way, yes. By challenging your balance and forcing those sensors to work overtime, you're basically saying, hey, brain, pay attention, this information's important.
Which could, in theory, help those neural connections get stronger, more precise.
Right. It's like practicing anything else. The more you do it, the better you get. But of course, we got to be real. This study was pretty small.
And they only looked at a specific type of stroke, right?
Yeah, mainly ischemic strokes, where a blood clot blocks blood flow in the brain. So we need more research to see if this holds true for other types of strokes.
Yeah.
And we need to follow people for longer to see how long these benefits last.
Totally. But it's still super promising. It makes you wonder, what if we could actually see what's going on in there? Like actually visualize the nervous system and how it changes with this kind of therapy.
Now you're talking. And it just so happens that our next study dives into exactly that. Neural network segmentation of disc volume from magnetic resonance images and the effect of degeneration and spinal level. It's a mouthful, I know.
But it's about using technology to measure parts of the nervous system with insane precision, like way beyond what we could do before.
Exactly. And while it doesn't directly involve stroke patients, it focuses on the spine. which is basically the information superhighway of the nervous system.
Because all those signals from the brain to the body, they got to travel through the spine, right?
Right. Think of it like this. If the brain is the control center, the spine is like the network of cables, carrying all the important messages back and forth.
Okay, so tell me more about this imaging technology. What are they actually looking at?
So they're focused on these things called intervertebral discs. You know, those little cushions between the bones in your spine?
Yeah, I've heard of those. They're like shock absorbers, right?
Exactly. And they're using this really sophisticated type of artificial intelligence called a convolutional neural network, or U-Net for short, to measure these discs with crazy accuracy.
Okay, I'm going to be honest. AI, neural networks, it's all a bit over my head. In simple terms, why should I care about accurately measuring spinal discs? Is it just about back pain?
That's a great question, and it's about way more than just back pain. Imagine this. We're teaching a computer to spot the tiniest, most subtle changes in hundreds of images of these discs, stuff that even the most trained human eye might miss.
So it's like having a super-powered magnifying glass for the spine.
Exactly. And this level of detail, it opens up a whole new world for understanding how even tiny changes in the spine can impact the entire nervous system.
So it's like we've gone from those old blurry x-rays to like high-def 3D maps of the spine. Wild.
It really is remarkable. The level of detail we can see now is incredible.
And this could help with so much more than just diagnosing back problems, right? Like, could this tech eventually help personalize therapies for stroke patients, especially when it comes to proprioception?
Now you're connecting the dots. Remember, a stroke can really mess with the communication lines between the brain and the body. That includes those proprioceptive signals we've been talking about.
So if we can use this imaging tech to pinpoint where the breakdown's happening in the spine,
It's like being able to zoom in and see the exact spot where the signal's getting lost.
we could target those areas with more precise therapies, maybe even prevent further damage.
Exactly. Imagine being able to see not only the stroke damage in the brain, but also how it's impacting the flow of information all the way down the spinal cord. The possibilities for personalized rehab are huge.
It just blows my mind. Something as basic as retraining your body's sense of position, that proprioception, could be a game changer for stroke recovery.
It speaks to the interconnectedness of our bodies and brains. It's not just about muscle strength. It's about those intricate communication pathways. And these studies, even though they seem kind of separate at first glance,
They're totally different worlds almost.
right, but they're both giving us these amazing glimpses into how the nervous system works, how resilient it can be.
And that's what makes this whole thing so hopeful, right? There's still so much we don't know, but with research like this, who knows what breakthroughs are on the horizon?
Absolutely. Especially for conditions like stroke that affect so many people. It's a really exciting time to be looking at these questions.
It really is. And for anyone listening who's ever had that weird feeling of their brain briefly losing track of their body, like, wait, where'd my foot go?
Happens to the best of us.
Right. That's your proprioception doing its thing. And thanks to research like what we talked about today, we're getting closer to understanding this amazing sixth sense that most of us never even think about. Until it acts up, of course. But that's a deep dive for another day.